If you want to have a look at some of these parts on here.
What a contraption, guys and girls. Just check out this.
We have our AC input here. Proper big blocks on this so they can handle good amps. You have your earth coming in.
You've also got an earth on the case as well, down there.
Got an earth on the case, yeah. But I will explain why I've not hooked up the earth here, and that is because out of inverters you don't really get a single phase. You actually get a split phase, which is like if I got a meter on this and touched it to the battery's ground, I'd get about what would it be, 120 volts. Which is like taking a centre tap in a way.
Yeah, it's like taking a centre tap, yeah.
From a transformer. So the reason I didn't earth that is because in the breaker box in the house you have a meeting of the neutral and the earth, which both come together.
In the UK this is.
In the UK,
I don't know what it's like
yeah.
for other countries, but in the UK that's how
it should be the same wherever you go, but don't take a word for it.
Yeah.
And if that was connected to that, it would obviously short it out straight up. So that's why this is meant to be wired before the bridge between this and that. It can happen after, you know, after the consumer unit, because that doesn't come into any of this. As for the earth, that is just supposed to go, where is it? I think that's just meant to go to the ground as an earth spike. But you do want to be careful. I'm not 100% on this.
There are people out there who's popped inverters doing this exact same thing, you know, hooking up the earth to the neutral. Well, just hooking up the earth to the earth on the thingy, because the earth and the neutral are linked together in the switch box in your house, the fuse box in your house, or the trip box in your house. It causes it to pop. So.
But obviously, if you've just got a plug on the end of this, like, well, not like that.
Not like that, but you know.
Bloody live. It's not anymore, but yeah, if you've got a plug like that on the end, you would actually connect up all of them. You connect up the earth, and the other two, you know, the neutral and the live, because there's obviously no meeting in a plug between the neutral and the earth. But we'll experiment with it a bit more.
It's not like we're going to pop it. Not at them amps.
It's got a 63 amp breaker on it for the output, which is only what our breaker is that's coming into the house.
Our main input breaker is only 60 amps.
Yeah, so the input is 80 amps because it has a big charger on this.
Yeah, the
charger on this will draw about 4 kilowatts if we've got it set to maximum, which we can't do because it will boil these batteries. We'd need a much bigger battery bank. It's got all sorts of different settings on it. You can change the frequency output. You can change the cut-off voltage, which means if the voltage sags a lot on your grid, your incoming voltage, then it will switch over to the inverter. And you can change the tolerances by using that. There's a few charging options on here. If you look at this little graph, it tells you what the rotating switch, it corresponds to that, and it tells you which batteries require which number.
See, we've got a mixture of a lot of those. We've got a mixture of number 1, I think, Gel USA, isn't it? What's the difference between AGM 1 and AGM 2?
I'm not.
Oh right, they've got different float charges. Oh,
yeah,
right.
But
so we've got a mixture of steel. No, we've not. We've got an open lead acid cell. We've got one of those.
We've got a gel cell.
We've got a gel cell, and we've got
an AGM. 2
AGMs.
Yeah. This one's really nice, this inverter as well, because it does
desulfate.
Desulfation.
Yeah, which is nice.
Which is really good.
Which just nukes the battery at 15.5 volts.
Yeah, for 4 hours max, so it doesn't boil off your stuff.
All of your thing.
It's a safety feature.
Nice. What does that say there? It says, if I can get the camera, warning, high internal voltage. LOL.
240 volts ain't high.
When you're playing with Tesla coils, then that's high voltage.
And that's still not really. That's the tip of the iceberg.
Yeah, exactly. You can go way more than that. So, guys and girls, awesome!
And we'll probably wire it up later on and do another video and show you the UPS function of it. We'll just quickly rush it. This is going to probably go in the shed in here and be all locked up. And it's going to run. The house is going to run through it.
Yeah, basically we're going to run the
battery backup. We're thinking of having an economy 7 system like photonic induction did.
We had our economy 7 system turned off when we realised just how much it was. But now we plan on putting the economy 7 back on, because if we can charge up batteries, the bank of batteries, efficiently, yeah.
And then if we could get the house partly during the day.
Yeah, exactly. Say even if it was powering it just during cooking times, you know, while I was cooking all the dinners, because we don't have gas in the house. The only thing that's gas in our house is the boiler. Everything else is done via microwave.
Or
electric hob. Well, we don't even have a hob, no. So everything we do is literally in the convection microwave.
Or the grill microwave.
Yeah, they've got grills built into and all sorts. So
you just use that for everything.
Yeah. So yes. That would work well. So we use that to then charge the batteries up on economy 7. Or we could cut our power bill down no end.
This is the cable we're going to use, which is much better. Oh, there we go.
Much better.
I had to cut through that with bolt choppers or a hacksaw. Yeah, it's fixed stuff.
Yeah.
It's.
The only thing that will limit us is the battery terminals themselves.
Yeah. Nice thing is about this side, it should be low voltage. Well, it will be, but you have to watch out with these, because if this is energising your house, this inverter, and you touch one of the poles on any part of the battery, it will give you a shock, because you're the ground that is going to the consumer unit, in a way. And there is no way to stop that.
It's just how they are.
It is. If you ground one of these, then you're creating a short circuit, which again is bad for your inverter.
Pop the inverter. You don't want to do that, guys and girls.
This is supposed to have all sorts of protection on it, but I don't really want to try it out.
Yeah, so you don't. You always treat it as if it hasn't got the protection on it. You know, just to play safe. I mean, did I get all the thing? I've got all these different modes on it. What's that? Line mode. INV, fast charge, float charge, alarm, over temp, overload, power, save on. Yeah, battery saving, battery type selector.
But our other plans for this is we'll be able to take it out of the house whenever we want, from the line into the house, and we're going to take it with us on a trailer when we're camping with the batteries.
This massive thing.
And we'll be able to use the kettle, fan heater, everything.
It's a bit over the top though, don't you think?
It is a lot over the top.
12 kilowatts?
A lot over the top, but...
Camping we need like, what, 4 kilowatt max? Just because we can use like the fan heater, like one of those, wherever it's disappeared to.
But this is the only one we've got, and I'm not shelling out any more for another one.
Nah,
so we'll just take that. On a trailer it doesn't really matter.
It's got an owner's manual too, I wonder if it's in English.
It's not bad actually, I had a look at it on online.
Ah, right.
We'll probably put a link in it.